Welcome, I'm Andrew Hardy from NXP Semiconductors. Today, we're going to talk about the importance of building resiliency and efficiency across factories, buildings, and cities. To do that, we're going to dig into projected world trends that we have to consider in our future designs. Then we'll talk about imminent threats and forces that are working against us. We'll examine the priority areas that we should focus our resources on. And then we'll also outline barriers of our existing infrastructure. And then finally wrap up highlighting solution to alleviate these barriers. So let's get started. So we're going to start off with some world projections that'll help support the reason for having resiliency and efficiency in our facilities. First of all, the world population is expected to grow 2 billion by 2050. The global GDP is expected to double by 2035. All this combined means there's going to be more connected smart devices in our world. We're expecting 75 billion new devices to be out in the world by 2030. And with that comes a greater energy consumption, which grew 5% last year, outpacing the renewable energy and impacting our CO2 emissions. So let's dig in a little further into some of the forces that are working against us. First of all, our infrastructure is inefficient and fragile as it stands today. Nearly half of all the global waste is caused by these manufacturing inefficiencies. Even up to 30% of delivery trucks run empty, wasting fuel and time. And there's downtime costs in manufacturing industry that are reaching upwards to $650 billion every single year. We also have an energy source issue due to the fact that we have slow growth of renewable power, and we're not on path to hit zero emissions by our goal of 2050. We also have bad actors that are providing sophisticated threats that are outpacing our security of our infrastructure. A recent 5-day shutdown cost Colonial Pipeline in 2021 $4.5 billion due to a ransomware payment strike. Further to that, manufacturing was most attacked sector last year, accounting for 23% of the reports of ransomware alone. And then last, there's simply not enough people to cover the demand and jobs that we have today. There's a global talent shortage of 85 million people by 2030. And further to that, there are safety concerns as deaths from workplaces and accidents and diseases reached 3 million. As an industry, we have to build a path to resiliency and efficiency. Our 4 focus areas need to be on the efficiency of these factories, buildings, and cities, safety, productivity, and last but certainly not least, cyber resiliency. So now that we've covered some of our goals that we have as an industry, let's also talk about some of the barriers we face with our existing infrastructure. First and foremost, there is a latency and a cost of sending all of our data to the cloud for decision making to exist only in that location. Further to that, there's a lot of legacy, hierarchical systems, and a topology that is set up for single points of failure, and an IoT and OT separation in the factories. There's low awareness and high consumption of energy across the board. Systems are designed without security. And last but certainly not least, there is a disparate, unscalable software across all of these systems. These are 5 areas that we have to focus on if we're going to truly build a resilient and efficient infrastructure. So how do we do that? With NXP, we are focused on 4 critical areas. First, edge computing. Second, machine learning. Third, end-to-end security. And fourth, real-time communication. We will cover each of these in greater detail. The first solution we're going to cover today is secure edge processing. Now, secure edge processing really starts from moving a lot of the decision-making that exists today in the cloud down to the edge. What that does is it enables real-time analytics and actuation with the combination of machine learning that is not hampered by network latency of sending data back and forth to the data centers to make decisions. Secondly, the reduction of the data center necessity also removes the need to access the network and lowers our overall cost of actual solutions and real-time decision making. Third, it also protects our data by having the data only reside on the edge, but if we have to transmit to the cloud, we can do that in a semantic way versus actual real raw data. And then last, improving the overall security to having resilient solutions when the data centers are no longer accessible. So we talked about the importance of maximizing software reuse and also managing energy efficiency. To do that, we have offered an edge-verse edge computing platform that scales all the way from the lowest end microcontrollers up to high-end performance applications processors. And not to be forgotten, also a crossover device that is a good blend of performance and power management. By having this scalable offering, it offers our engineers the ability to reuse their software up and down their different applications, whether or not that's high performance or low power for their particular applications. Machine learning on the edge offers us more efficient real-time decision making versus opposed to going to the cloud for all of our decision making. It reduces the overall network costs and reduces latency as well. Some great examples of applications leveraging machine learning on the edge are facial identification for secure access in and out of buildings to improve the traffic flow, anomaly detection on factory equipment to help prevent failures and reduce maintenance costs. Remember, downtime in the factory is extremely costly. Or even potentially pattern detection for identification of potential criminal behavior or threats in our cities today. Machine learning on the edge provides real-time decision-making for these critical applications where a decision is required immediately such that we can improve the overall resiliency and efficiency of our factories, cities, and buildings. Network interoperability and accessibility are critical to making a transition to a resilient and efficient infrastructure. Existing infrastructure uses a lot of legacy protocols that do not inherently interoperate with the newer protocols. Hierarchical networks also create single points of failure. Multi-protocol IP-based solutions such as NXP's i.MX RT devices offer a solution to this problem. These crossover MCUs allow different networks such as TSN, EtherCAT, Profinet to share information seamlessly, locally, at the edge, and to the cloud. Security threats pose the risk of significant financial or brand harm and potentially life and death. Existing infrastructure often do not have security capabilities to defend against these more sophisticated threats. There are 4 important areas to focus on when designing for resiliency. First, securing the manufacturing of your device, such as using hardware root of trust and firmware secure provisioning. Second, securing the communication to and from the devices using TLS and symmetric encryption. Third, securing the operation of your device, leveraging secure boot and key storage. And then last, maintaining the security of your device through the entire lifetime of the device, which includes software and credential updates over the air. At NXP, our edge computing platforms are designed grounds up with these 4 pillars to help protect your devices over their entire lifetime. The growth of our population, the number of devices, and our demands for energy make it essential as a society that we focus on building more resilient and efficient infrastructure. Scalable and secure edge computing platforms with seamless connectivity will help us overcome the barriers of the existing infrastructure. I encourage you to reach out to your local NXP team to learn more about our secure edge computing platforms and how we can help in your effort to building a more efficient and resilient infrastructure. Thanks for taking the time to listen on this very important topic today.